Hello guys, in today's video we are tackling equations where y and x are so tangled together that you can't easily solve for y on its own. That's where implicit differentiation comes to the rescue. It is a powerful technique that allows us to find derivatives without needing to isolate y. You might not realize it, but implicit differentiation is incredibly useful in real-life scenarios, like modeling the motions of objects, understanding the relationship between variables in physics, or solving problems in economics where variables depend on each other in complicated ways. Let's break it down and see how it works. So, implicit differentiation, to solve it, we have two things that we have to consider. The first one is we have to differentiate both sides of the equation with respect to x, treating y as a differentiable function of x. Then afterwards, we have to collect the terms with the y dx on one side of the equation and solve for the y dx. Basically, let's go through a question to explain the concept. So we have to find the y dx if y squared is equal to s squared plus sine of xy. In this question, note, to differentiate this, right, first of all, we differentiate both sides. So in this case, we have d dx of y squared equal to d dx of s squared plus d dx of sine of xy. Now, if we differentiate y squared, we have 2y. But in this case, we are not differentiating with respect to y, we are differentiating with respect to x. So you always have to add the y dx. This is equal to, now if we differentiate this, you have 2x. Now since we are differentiating with respect to x, there is no need to add the y dx, we just leave it as it is. Plus, now to differentiate sine of xy, remember we have to use the chain rule. So to differentiate sine of xy, we have to use the chain rule. So to use the chain rule, remember let's say we let u to be equal to xy. Then if u is xy, let's say we can have this to be v. Then we can say v is equal to sine of u. So we have to first of all differentiate u. So the u, the x, remember this is also product rule. So for product rule, we hold the first one in place, which is x, and we differentiate the second term. Now if we differentiate y, we have, since y is not x, we have dy dx, then plus, afterwards we differentiate the first term, which is x. So if you differentiate x, you have 1, you multiply it by y, you have this. I hope this is clear enough. So what I did there was, now when you have u is equal to xy, you can have f to be x and your g to be y. So f prime is equal to 1. Now g prime, since we are differentiating with respect to x, normally if we differentiate y, you should get 1. But since it's not x, we have to add the y dx. So 1 times the y dx is y dx. So using the product rule, we have f of g prime plus g of f prime. So f is your x, g prime is the y dx, plus g, which is y, and your f prime is 1. So if you multiply, you have the same thing. So this is what we have over here, basically. I hope it's clear enough. Okay. Now since this is u, we can have dv du to be equal to, if we differentiate sine, we have cosine of u. So in that case, dv dx is equal to dv du dot du dx. So let's continue. We can have dv dx equal to, now dv du was cosine of u, du dx, we had x dy dx plus y. Cosine of u, note that u is just xy, so we have this. So we can go back to here. Now if we differentiate sine of xy, this is what we have. So in this case, we have cos of xy multiplying x dy dx plus y. So we have 2y dy dx, 2x plus, now we can distribute cosine of xy here and here. So if we multiply it by the first term, we have x cosine of xy dy dx, and if we multiply it by the second term, we have y cosine of xy. So that's the step one. We differentiated both sides. Now we have to collect the terms with dy dx. So we have dy dx here, here. So what we can do is we can bring this dy dx to the left hand side, or we can send this dy dx to the right hand side. Any of them works. So let's bring it to the left hand side. So in that case, we have 2y dy dx. If this crosses the equal sign, it becomes negative. So we have minus x cosine of xy dy dx, and this is equal to 2x plus y cosine of xy. So we can factorize our dy dx out. In this case, we have 2y minus x cosine of xy, and the right hand side is 2x plus y cosine of xy. So to find y ds, we just have to divide through by this term right here. So our dy dx is, on the right hand side, we have 2x plus y cos of xy. Then we divide by 2y minus x cosine of xy. One thing that you have to notice, you can't cancel this term with this. It's not possible. So you just have to leave your answer like this. I hope this is clear enough. So using implicit differentiation, we combine the chain rule. Sometimes we also have to do the product rule. It's kind of tedious, but if you follow the step, it's way easier. Now let's look at the second question. For question 2, we have to find the second derivative if 2x cubed minus 3y squared is equal to 0. In this case, before you can find the second derivative, we have to find the first derivative, right? So if we differentiate this first term, we have 6x squared, and if we differentiate this second term, remember we are differentiating with respect to x. So if we differentiate it, you have to have negative 6y, but since it is not x, you have to add dy dx. And if we differentiate 0, which is a constant, you get 0. In this case, we can just send the negative 6y to the right hand side, so it becomes 6y dy dx. So to find dy dx, basically we have to divide both sides by 6y. So we have 6x squared out of 6y equal to dy dx. And if we do so, we have 6 cancelling 6. So we are going to just have dy dx is equal to s squared out of y. So this is the first derivative. Note, we want the second derivative. Now for the second derivative, remember we have two functions and these two functions are dividing each other. So which approach do we think we should use? Guess. We have to use the quotient rule. So we have the squared y over the x squared. This is the quotient rule, remember, is this. In this case, our f is x squared, our g is y. If we differentiate f, we have 2x. And if we differentiate y, remember if we differentiate y, you just have 1. But since it is not x, you multiply it by the y, the x. So if we do our substitution, we are going to have the squared y over the x squared. This is now g is y. F prime, we had 2x minus our f, which is x squared. Now g prime, so g prime we had dy dx, so we have dy dx here, and g squared, so we have y squared. So this simplifies to 2xy minus x squared. But note, for the y dx, we've already solved it. We had x squared over y here, so we can just do our substitution. So we have x squared out of y, then out of y squared. So this is simply 2xy. Now if we multiply this by this, we have x to the fourth out of y squared, which can be written as 2xy out of y squared minus x to the fourth out of y squared. So over here, this y will cancel one of the y over here. So you just have 2x over y. Now, this right here simplifies to x to the fourth out of y cubed. I hope this is also clear. Okay, let's move on to the third question. For question 3 over here, we are to show that the point 2, 4 lies on the curve s cubed plus y cubed minus 9xy equal to 0. Then we have to find the tangent line and normal line to the curve. This is the solution. And remember, to show that the point lies on the curve, basically what you have to do is you have to substitute in the 0.24, right? So we have x cubed. So in this case, our x is 2, our y is 4. So we have 2 cubed plus y, which is 4 cubed, minus 9x, which is 2 times y. So if this simplifies to 0, then it means that the point lies on the curve. So 2 cubed is 8, 4 cubed is 64, 9 times 2 times 4, that simplifies to 72. So this is basically 72 minus 72, which is equal to 0. So since this is equal to 0, then it means we've shown that the point 24 lies on the curve. Okay, so that's the first part done. Now the second part is we have to find the tangent line. Okay, so remember, to find the tangent line we need our slope, and remember that your slope is always your dy dx. So we have to differentiate. So having s cubed plus y cubed minus 9xy equal to 0, we have to differentiate the left hand side and right hand side with respect to x. So if we differentiate s cubed, we are going to have 3s squared. And if we differentiate y cubed, we have 3y squared. But since it is not x, we add dy dx minus 9. Now remember, over here, we have to use a product rule. So for product rule, we write the first one, which is x. We differentiate the second term, we have dy dx plus, now we differentiate the first term, we have 1 multiplied by the second term, which is just y. And if we differentiate the right hand side, you always get 0. So we can expand this. So we have 3s squared plus 3y squared dy dx minus 9x dy dx minus 9y equal to 0. So we just have to group the dy dx, right? So we have 3y squared dy dx minus 9x dy dx. Then we can send the rest to the right hand side. So if we send, we have positive 9y, then minus 3s squared. So we can factorize dy dx out. So we just have 3s squared here minus 9x, and this part is 9y minus 3s squared. So to find dy dx, we just have to divide through by 3s squared minus 9x. So dy dx is 9y minus 3s squared out of 3s squared minus 9x. You can leave your answer like this, or clearly you can see that 3 is a factor in both the numerator and the denominator. So you can factorize it out. So you have 3y minus s squared. In the denominator, you have 3 outside, so you have s squared minus 3x. So this cancels that. So this is equal to 3y minus s squared out of s squared minus 3x. Note, you can't cancel out this and this. It doesn't work that way because of the subtraction in here. So we just have to leave our answer like this, right? So this is your dy dx. Now after knowing, let me copy this. Okay, so we know dy dx is equal to this, but we want our slope. So to find our slope, we have to replace x and y with 2 and 4. So in that case, we have dy dx equal to 3 times y, which is 4, minus x, which is 2 squared. S squared is 2 raised to the power, 2 raised to the power 2 minus 3 times x, which is just 2. So 3, 4 is 12 minus 4, then 4 minus 6. So did I copy this right? So over here, oh sorry, so I made a mistake here. So this was supposed to be y squared because of this here. So in this case, this becomes y squared and and there is another y squared here, and there's another y squared here. So it means that this is y squared, and if you put in the values, you are going to end up getting 4 squared here, so this is 16. So the numerator simplifies to 8, denominator simplifies to 10, and this is 4 out of 5. So for the tangent line, remember you have y minus y1, x minus x1. So our y1 is the y, which is 4. Our m, which is the slope, is 4 over 5. X minus x1, which is just 2. So we can just cross multiply, right? If we do so, we have 5 multiplying y minus 4. This is equal to 4x minus 2. So this simplifies to 5y minus 20, 4x minus 8, and this is 5y. We can send the negative 20 to the right hand side, so it becomes negative 8 plus 20. So 5y is 4x, then plus 12. So the goal is to find your y. So y is 4 over 5x plus 12 out of 5. So this is the equation of the tangent line. The question also asked us to find the equation for a normal line. So for the normal line, note the normal line is always perpendicular to the tangent line. So in this case, we are going to have, instead of m, we have negative 1 out of m. So x minus x1 here. So we have y minus y1, which is 4. Then negative 1 out of 4 over 5. Then x minus x1, which is 2. Y minus 4, remember, negative 1 over 4 over 5 is the same as negative 5 fourth. Then x minus 2. So if we cross multiply, you have 4. This is y minus 4. Negative 5, this is x minus 2. So we have 4y minus 16, negative 5x plus 10. We want y, so we make y the subject. We send negative 16 to the right hand side. It becomes positive. We have 4y equal to negative 5x plus 26. So we can have y equal to negative 5 over 4x plus 26 out of 4, which is negative 5 over 4x. 26 out of 4 is the same as 13 out of 2. So yeah, this is how to solve such a question. So this is our tangent line, and this is our normal line. I hope this also helps explain the concept a little bit better. Okay. Now, let's move on to the next question. For the next question, let's find the y dx in, so okay, we have 3xy plus 7 squared is equal to 6y. So how do we solve this? Note, to solve this, first of all, you have to use the chain rule. So we have to differentiate the left hand side and right hand side. To differentiate the left hand side, remember, you can have u to be what is inside the parenthesis. So in that case, if you are to represent the left hand side by y, or if it is going to be confusing, we can have v, which is just u squared. Excuse me. So in that case, to differentiate the u with respect to x, we can have 3 is a constant. Remember, x and y, this is product. So we hold the first one in place, differentiate the second one, plus we differentiate x, we have 1 multiplied by y, we have this. Then if we differentiate 7, this goes to 0. So we just have this. Then our dv du is just 2u. So now dv dx is just dv du multiplying du dx, which is basically, now dv du is 2u, but u we had 3xy plus 7, and our du dx is, we have multiplying 3 here, then we have x dy dx, then plus y. So we can simplify this further. So 2 times 3 right here will give us 6. So we have 3xy plus 7. Then we have x dy dx plus y. Now let's differentiate the right hand side. If we differentiate the right hand side, which is a 6y, this will give us 6. Now since it is no x, we have to add dy dx. So now let's expand the left hand side. So to expand this, if we distribute the 6 here, we have 18xy. Let me write this well. We have 18xy plus 42 x dy dx plus y equal to 6 dy dx. Now we can distribute this 2, so we have 18x squared y dy dx plus 18xy squared, then plus 42x dy dx, then plus 42y, then equal to 6 dy dx. So now the next thing to do is to group like terms. So we have dy dx here, here, here. So we can group it on the left hand side. So now we can have dy dx. So this part is going to be 18x squared y plus 42x. Then if this crosses the equal sign, it becomes negative. So we have minus 6 here. Then on the right hand side, we can send the terms that has no dy dx attached. So we can have negative 18 sy squared. Then we can also have minus 42y. So to find dy dx, we just have to divide through by this. So let me do it here. So our dy dx is, remember, negative 18 and negative 42, we can factorize 6 out. So if we factorize 6 out, we have negative 3xy squared, then minus 7y. Over here, we can also factorize 6 out. So if we do that, we have 3x squared y plus 7x minus 1. So 6 cancels out 6. So our final answer is negative 3xy squared minus 7y out of 3x squared y plus 7x minus 1. I hope this is also clear. If you don't understand anything, just let me know in the comment section and I'll try as much as possible to explain. Let's look at our last question. We have to find dr d theta in sine of r theta is equal to 1/2. So in this question, we have to use the chain rule, right? So we have to use the chain rule. So we differentiate the left hand side and the right hand side. So we can let our u be what is inside the parenthesis. Then this means that we can represent this whole thing by y, right? So if we do that, we have sine of u. So the u, remember we are differentiating with respect to theta. So the u d theta, in this case, we will still use the product rule. We hold r in place, we differentiate theta, we get 1, then plus. We differentiate r with respect to theta and multiply it by theta. So we have theta dr d theta. I hope this is clear. And then to differentiate y, we have dy du. If we differentiate sine, we have cosine. So if we want dy d theta, this is just equal to, so in this case we're going to have du d theta multiplying dy du. So if we simplify, this is just r plus theta dr d theta multiplying dy du, which is cosine of u. So cosine of u by u is r theta, right? Okay, so this is for the left hand side. So for the left hand side, we had we can distribute cosine of r theta. So we have r cosine of r theta plus theta cosine of r theta multiplying dr d theta. Now for the right hand side, if we differentiate 1/2, we get 0. So now let's group like terms, right? So we have theta cosine of r theta dr d theta. We can send this to the right hand side, then it becomes negative. So we have this. So to find the r d theta, all that we have to do is to divide through by this. So the r d theta is negative r cosine of r theta out of theta cosine of r theta. So in this case, this will cancel this. So we have our final answer to be negative r out of theta. I hope this is clear enough. So we've gone through several questions to explain the concept of implicit differentiation, and I hope this helps. Now, implicit differentiation might seem tricky at first, but with practice, it becomes a second nature, just like solving puzzles. If you found this helpful, give it a like, subscribe for more math magic, and stay tuned for the next video, where we'll dive even deeper into the world of calculus. Thank you. See you in the next video. Bye.